Good day everyone, you're listening to Easy Stats. We are going to teach you how to do the following using SPSS. Sit back, listen, and enjoy.
In this video, I'm going to discuss about independent sample t-test, and we'll also discuss why we need to use independent sample t-test, or in what conditions do we use independent sample t-test. I have an example of this GPA core data, and in this example, I want to know whether gender is having any significant difference towards GPA score. And this, in gender, I have two values, male and female. And I want to know, is there any significant difference between male and female towards GPA score? Now, under these conditions, we can use independent sample t-test. So in this case, I have two variables. One is gender and the other one is GPA score. In gender, the measurement scale is nominal and the values are exactly two levels, male and female. And GPA score is a scale data. Now, when we have a nominal data, which is exactly two levels, and I want to know the difference towards GPA score, which is scale data, then I can use t-test. To use t-test, there must be exactly two levels. And for this more than two levels, I need to, or I can use ANOVA, but I can't use t-test. The important condition of t-test is t-test can only be used when the levels are exactly 2. So I'm clearing my objectives to what I want to do or what I want to analyze. I want to analyze whether there is any significant difference between male and female strengths towards getting GPA score. I'm doing a statement of a null hypothesis. There is no significant difference between male and female towards GPA score. This is my null hypothesis. I'll start the analysis. And to do that analysis, in the menu, click Analyze, then Compare Means, then Independent Sample t-test. So the gender is a group variable and GPA score is the test variable. Click the group variable and then click Define Groups. 1 is male and 2 is female. After this, click OK. Now, this is the output window. So in the first table, we have gender, female and male. These means are given here. The mean of the female is 3.32 and the male is 3.4031. So now, is there any difference between male and female towards the GPA score? Now to do this one, we have already formulated the null hypothesis that there is no significant difference between male and female. I need to check the difference or the significance value. This is the value I need to see in the second table. The significance value here is 0.980. This is the value. If p-value is the significant value is less than 0.05, then we reject the null hypothesis. The significant value in this case is 0.980. So we are not going to reject the null hypothesis. It means there is no significant difference between male and female strengths in getting GPA score. This is a simple example which explains how to do the analysis of independent sample t-test. Thank you! Hello! In this video, I am going to discuss about paired sample t-test using SPSS. First, let us discuss Why paired sample t-test need to be used, or when paired sample t-test analysis will be used. In a case when we have two samples which are dependent and we want to compare these two samples whether there is any difference between the two samples, then we use paired sample t-test. The word itself, paired, in the sense they are compared, they are dependent. The simple example is some 32 employees are taken that we trained on a method. Before training, their scores are recorded in a test, and after training, the scores are recorded in another test. Now, I want to test whether the scores before training is having any significant difference to after training. I have this example GPA score where I have two variables, pre-test scope and post-test scope. These two variables are scaled data, and I want to know whether there is any significant difference between pre-test score to post-test score. So the conditions for using this paired test is the two variables should be scaled data and they must be dependent. Let us start the analysis. First, I go for analyze, and then compare means, and then paired sample t-test. First, select pre-test. Next, select post-test. See, these two variables are taken as a pair and then click OK. Now, this is the output screen where we have the first table. Pre-test mean is 79.2813. The second one is the post-test where we have 83.5 mean. Now, is there any difference between pre-test and the post-test? To figure it out, we need to check the significant value in the second table, which is called pair sample correlations. And paired sample test where we need to check the significant values. Here the significant values is 0.001. The null hypothesis of what I made is there is no significant difference between pre-test and post-test scores. Now, if p-value or significant value is less than 0.05, then we reject the null hypothesis. The important question is, why am I taking a 0.05? It's because my confidence interval is 95%. That is why I'm taking it. If the p-value is less than 0.05, then we reject the null hypothesis. In the output screen, the significant value is 0.001, which is less than 0.05. Then, we are going to reject our null hypothesis, which I interpreted as there is a significant difference between pre-test and the post-test. Now, this is how we are going to formulate an example on how we are going to interpret whether there is a significant difference between pre-test and post-test. Thank you.
I'm going to discuss one-way ANOVA using SPSS. This data I have has three variables: gender, test scores, and training method. The organization uses three methods of trainings: traditional method, machine learning method, and traditional machine learning method. Test scores is a scale data, and the training method is a nominal data. There are more than two data, so I'm going to use one-way ANOVA. In the analysis process, the first thing we need to do is to click Analyze. Click Compare Means, then click One-Way ANOVA. I'm going to take test of scores as a dependent list, and training method as the factors. And once I click OK, we're going to know the difference between the task scores and the training methods. For wise analysis, we need to click post hoc, then click keep. Then you can see the significant level, which is 0.05. Check continue, then click OK. The table have three groups, and the significant value is 0.660. The null hypothesis is there is no significant difference between the training methods towards the scoring marks. If p-value is lesser than 0.05, we need to reject the null hypothesis. In our data, it is 0.6, so it means we need to accept the null hypothesis. Therefore, there is no significant difference between the training method and the scoring marks.